Good morning, all. Sustainability and goals regarding that are on the top of the agendas of most of us. It's for our private life, but also mainly for business. For us at Tata Steel, sustainability is at the heart of our strategy. It has always been and it will be. In fact, it's at the foundation of our company. We have a heritage of looking after the welfare of our employees and the wider society, and it remains a key purpose of our Tata Group today. As far back as 1900s, Tata Steel pioneered a number of welfare improvements, including an 8-hour working day, free medical and maternity benefits, and retirement. The company was founded more than 150 years ago with the aim of financing and starting projects to improve the life of people. And today, 2/3 of Tata Sons is owned by a philanthropic trust. More recently, in the pandemic, Tata Sons has committed 115 million euros to COVID relief, while Tata companies are upgrading hospitals, supplying life-saving ventilators and oxygen, and trading medical staff. Within the sustainable development challenges, climate actions and decarbonization is both a huge challenge and opportunity for all of us. And while recognizing that sustainability is about a broad range of issues, I like to focus most of my presentation today on decarbonization. In doing so, I'll focus on my European market business, European markets, and therefore Tata Steel in Europe. Let me give you a brief introduction about my company. We are the third largest producer in Europe with a crude steel production of about 12 million tons a year. Our steelmaking sites are in Netherlands and in the UK, and we have downstream manufacturing sites and distribution service centers across Europe and other parts of the world, including North America. Our steel is used by most demanding markets, including construction, infrastructure, automotive, packaging, and engineering. Tata Steel is among the most carbon-efficient producers in the world today. Our IJmuiden site, for example, in Netherlands, is the third lowest CO2 emitting integrated steelworks globally. Yet, we all know that a benchmark performance on operating at near to technological limits today isn't good enough for the future. In terms of decarbonization, we have set ourselves a target to reduce our steelmaking emissions in Europe by 30 to 40% by 2030. Clearly, then, we will need to make significant investments to decarbonize our assets in the coming years. Today, I'm going to be discussing these issues which, in my view, are critical to deliver a timely, robust, and efficient decarbonization of not just my business, but also the whole European steel sector. In doing so, I'll also take you through the journey that Tata Steel in Europe is going through to navigate this transition. Steel is, as we all know, a sustainable material that has been and will continue to help decarbonize society. Steel is a permanent material that is used but never consumed. Once made, it's there to serve society for many generations. And being the most recycled material in the world, it's also the engine of the circular economy. However, we of course recognize that currently the production of virgin steel from iron and iron ore is a significant cause of greenhouse gas emissions around the world. The decarbonization of steel production is a priority for the world and for me personally. But I think there is not just one solution to our decarbonization transition, not just one technology. It requires the actions of many, where companies, governments, policymakers, and markets need to work together to solve this. And it's not only about cooperation. It's also about managing uncertainties. It's about whether technologies and appropriate infrastructure are ready to use and are affordable. And therefore, I believe we will be multiple horizons in the European decarbonization transition, because available and affordable solutions in the 2020s and the 30s could be very different to solutions in the 2040s and beyond. Decarbonization technologies for world-scale steel production are still in development, and they include carbon capture and direct carbon avoidance through hydrogen or electrolysis. all in combination, of course, with increased levels of scrap steel. Technologies differ in their states of readiness. Their affordability is different from one country to the next, and also in different geographies or even in different asset configurations. National funding can also play a role in a technology's affordability. But I do believe there are risks if the steel market becomes prescriptive about the decarbonization technologies, for instance, by supplier key performance indicators of steel specifications. I think this would be a barrier to the market finding the best decarbonization solution, which can take local circumstances and policies into account. There is no clear single winner in the possible technology solutions. A winning technology which could decarbonize all steel producers wherever they are in the world. Personally, I don't think there will ever be one. Instead, we each have to find the best solution using available and affordable technology that suits our individual circumstances. There is a responsibility on steel producers, on their customers, and others in the steel sector to help create a common understanding and agreement on a range of issues, including, for instance, how we define green steel. And we need to do it in such a way that respects the many different solutions that steel producers will use to decarbonize. Let's keep focus on the real objective, to achieve fast and large-scale decarbonization of our products and industry. One of the technology in development is hydrogen-based iron production. There is still to consider that we are in a development phase. But even if technology was ready today, there's not sufficient green hydrogen available in the world to satisfy the steel industry's needs. More renewable energy generation is needed, but also hydrogen distribution networks. Also, carbon capture technologies are still in development, though they are more mature in their technology readiness. But they are still need to be adopted for large-scale application to steel production sites. And such locations require infrastructure, for instance, to transport and store the captured CO2. So there's a big responsibility on our governments to create the right infrastructure and availability of affordable renewable energy, which will enable the decarbonization transition of the steel sector. Furthermore, there's a responsibility of policymakers and governments to ensure a fair and level playing field for steel in Europe. Preferably, the transition is facilitated by global harmonization of carbon pricing or taxing policies around the world. But if that is practically unfeasible, Europe needs to ensure a fair and level playing field within the EU, which prevents national differences, also a fair and level playing field between Europe and non-European countries, both from an import and export perspective. Now that there's the EU emission trading system benchmarks have been sharpened under the phase 4 of the scheme, and the value of emission allowances are trading above 50 euros per ton of CO2 today, the fair and level playing field is more than important than ever before. We are following closely the European Commission's draft on the development of a carbon border adjustment mechanism and the possible consequences for steel in that. There's also a role for steel consuming markets. It's clear that low carbon production requires significant investments and will come with higher costs than conventional steel producing methods. It's important, therefore, that our markets accept that lower carbon steel will need to command a higher price point. Our governments in Europe have chosen that the emission trading systems, the ETS, as a cornerstone of their climate action strategy. ETS drives up the cost of conventional steel making, even for carbon efficient mills like ours. By doing so, the costs of conventional steel are increasing, but this will help to drive innovation and investment in low carbon alternatives. As you know, energy intensive sectors like steel need further technology and infrastructure development and significant investment to decarbonize. These sectors are already making a contribution to the Europeans' decarbonization by having to buy emission allowances and thereby creating revenues to help to fund Europe's transition. In this system, it's important that our markets realize that there are costs arising from our government's chosen policy and that they lead to a higher production cost that cannot be borne by us as steel producers alone. These carbon costs have joined more traditional costs like labor and raw material, and they need to be passed on through higher steel prices. To create more awareness of how ETS affects Tata Steel, but also European steel industry, we have started to explicitly price for carbon cost in our steel sales. I believe that accepting the carbon needs to have a price is also a condition for a successful decarbonization transition. So I hope I've been able to explain the various interdependencies and the time needed to develop technology and infrastructure which will enable the steel industry to decarbonize. Let me also take you through our steps at Tata Steel in taking this transition. Circularity plays a key role in our decarbonization plans, both steel and iron circularity, as well as circularity by the byproducts from our production processes. But we also recognize that the foreseeable future, particularly as developing countries continue to industrialize, there will not be enough scrap to satisfy demand for steel around the world. Therefore, our roadmap includes various ore-based decarbonization options. Both virgin steel and scrap have to play a role, more in combination with each other in future, I believe. I see the promising potential of hydrogen-based production technology. At Tata Steel, we are working with partners to investigate options to develop a 100 megawatt hydrogen electrolyzer on our site in the Netherlands, which could feed our steelmaking processes and be connected to a hydrogen grid. And while we recognize the decarbonization potential of hydrogen is for iron making, we also recognize the issues around technology's readiness and affordability. And same as for the quantity of renewable energy needed to produce even green hydrogen for large-scale production. In Netherlands, for example, we would need every megawatt of wind power generated in the country's wind farms planned until 2030 to produce enough green hydrogen to satisfy our own needs. But of course, we are not the only electricity consumer in Netherlands who want this green energy. And so we will need to generate a lot more renewable energy in Europe to satisfy everyone's need and to satisfy decarbonization needs. We think carbon capture and its storage or utilization can play a key role, especially from a timeliness point of view. This technology could enable large-scale decarbonization already in 2020s. As the produced steel itself is not changed when using CCS or CCU, the technology allows for immediate large-scale use in existing applications, designs, and production technologies, adding to the speed of adaptation and hence decarbonization. When addressing climate change, we need to move fast, and carbon capture technologies have the potential to deliver with speed. We are working with partners along in other projects in Netherlands, which aims to develop a CO2 distribution network to support carbon utilization or storage. In the UK, meanwhile, Tata Steel is a founding member of the South Wales Industrial Cluster, in which partners are also preparing for carbon capture options. So we are preparing various decarbonization options, and the interplay with infrastructure, policy, and market acceptance will help us to navigate the best options at the right moment in time. As I've said, sustainability is at the heart of Tata Steel's strategy, and therefore it is addressed in our core business processes, including innovation and logistics. We have implemented the use of sustainability assessments to be used in new product developments in order to deliver a more sustainable product from a whole life cycle perspective. This innovation has been recognized with an award from the World Steel Association for Excellence in Life Cycle Assessment. This ensures we can create and produce new steel products with the help of society, to decarbonize. Products to be applied could be wind turbines, solar panels, low carbon buildings, electric vehicles, and preserving food. We are also taking actions now to reduce emissions associated with logistics. We operate the Zero Carbon Logistics Framework Initiative, in which we map, measure, and reduce emissions from transporting our steel to customers. In collaboration with partners, this helps us to improve our supply chains also from a carbon footprint perspective. I hope I've been able to take you through how we navigate the decarbonization transition from the perspective of a European-based supplier. And I hope I'm able to convey that we at Tata Steel are taking actions and actively working with partners to create the right options to deliver decarbonization transition. We also see significant roles for industrial partnership, policymakers, governments, and our markets. If therefore is one challenge that needs collaboration, it's this one on decarbonization. It requires a collaborative approach across many players in Europe. We in Europe have the potential to lead decarbonization to our steel sector. And I believe together we can make this happen and make a difference. Thank you for attending, and I'm happy to take questions in Q&A later. Thank you.